guys in the session. I'm going to talk today about a balancing act, and that is how do we balance fire hazard reduction in California, which is a highly fire-prone part of the world, with resource protection. I guess I'll just use that. I live in a part of the world that has a lot of the diversity of California represented in terms of physiognomy. We have, this is basically my backyard. This is, we have conifer forests in the higher elevations, and then we have chaparral, oak woodlands, grasslands in the lower elevations. And this complexity leads to complexity in fire regimes, and it also leads to complexity in how we manage these landscapes. Historically, the higher elevation conifer forests, as most of you know, burned in low intensity surface fires. Chaparral in the lower elevations never burned in low intensity surface fires, and has always been characterized by high intensity crown fires. Now, recently, Hugh Safford put out this study on Forest Service lands in California that looked at the deviation of fires over the last century from what we believe the historical fire regime was like. And essentially, he describes in this paper two different fire regimes: the Southern California fire regime dominated by shrublands, and the Northern California Sierra Nevada regime, which is mostly conifer forests on Forest Service lands. And it differs in the departure of fires in the last century from what we believe the historical regime was. These blues indicate landscapes that have missed fires in the last century relative to what we think historically was the case. The yellows and orange represent landscapes that have had more fires in the last century than we believe was historically the case. And so you can think of the state as basically two very different fire regimes. One of the complexities of all of this is that when you look at these two different fire regimes and you think about the balance between reducing fire hazard and resource protection, there's a conflict in those two when we look at the lower elevation chaparral relative to conifer forests. In conifer forests, you can do low intensity surface fires to keep the fuel loads down, and that actually is beneficial for resources in those systems because the communities assembled under that sort of fire regime. You get into chaparral and they're really incompatible. What you need to do to keep fire hazard down and safe for people is often incompatible with the resource protection in those landscapes. Now, this is just an illustration of the problem in the southern part of the state. This is from a paper we did a number of years ago where we looked across North America at different landscapes and at fires over, historical fires over the last century. And one of the things that you'll notice is the scale here for Southern California is like orders of magnitude higher than for some other regions in North America. So a much greater proportion of Southern California has historically, or has burned in the last century than in most other landscapes. The other thing to note is we've had big fire events punctuated this record over the last century. That's not necessarily always the case in other landscapes. For example, the Great Basin, we're starting to see an acceleration of big fire events. Now, this characteristic of chaparral having frequent fires and frequent big fires has led to an annual tradition, the Onion has described, Californians gathering to celebrate the annual wildfire tradition, where the residents take part in rituals, feigning shock that this could have happened to them. Now, I've always told students, ever since I started teaching, chaparral is a fire-adapted ecosystem. Well, I now feel that I need to recall those students and retrain them, because I don't think that's really a very appropriate way of describing chaparral as being fire-adapted. What we really need to think about is the fact that chaparral is adapted to a very particular fire regime, and that fire regime comprises high fire intensity, very often massive landscape burns, and fire return intervals anywhere from 30 to 130 years, we believe, is probably the historical condition in that landscape. And we think of in fire in this sense as a natural ecosystem process. And disturbances, in my mind, to this landscape are disturbances in the fire regime. In other words, when we perturb the regime, either by creating excessively long intervals between fires, for example, through fire suppression, or very short fire intervals due to accelerated ignitions, largely due to people, since in chaparral landscapes, most chaparral landscapes, people are the primary ignition source. Now, both of these perturbations could degrade the system and lead to a need for restoration. And so what I'm going to focus on today is trying to understand these two potential perturbations and which of these we should be most concerned about. Now, Paul Zedler created these two terms, which I think are a great way of summarizing the risks in chaparral management. He described these two potential perturbations as either senescence risk or immaturity risk. Senescence risk being due to fire suppression, which creates long fire return intervals, and we get unwanted changes in the ecosystem. Resprouters lose their vigor, seed production declines. In fact, seed banks may actually deteriorate. Immaturity risk, on the other hand, is when we have too much fire in the system, and we get very short fire return intervals. This is potentially a problem for species that regenerate strictly by seed, particularly shrubs, because they may not have enough time to replenish the soil seed bank. And also there's evidence that some resprouters need sufficient time between fires to replenish the carbohydrates in the burl. So I'd like to evaluate these two risks, and let's begin with senescence risk. Now, there's a lot of ways you can look at senescence risk. This is a map of Southern California. Shrublands, the chaparral shrublands here are sort of a tan color, and much of the landscape is shrubland. The red hash bars indicate landscapes that have had a fire in the last 100 years. And it's obvious there are very few parts of this landscape that have escaped fire. And so in terms of senescence risk, it suggests that maybe this landscape is not really at risk because we don't, even though we have practiced fire suppression, unlike conifer forests, we have not succeeded in fire exclusion, which is what happens in many of the conifer forests. And that has a lot to do with the way fires are fought. Another way of looking at this is try and evaluate how well these systems regenerate after long interval fires. And we had a chance to do this in the southern Sierra Nevada. This is Sequoia Forest here. This is Sequoia National Park. And there was a big fire down here. And these colors, the blue indicates chaparral that had had a recorded fire prior to this big fire, the McNally fire in 2002. And the reds indicate areas that had prior fires. We went into this landscape, and it was an extremely large fire, and it had burned a lot of landscape that had never had a recorded fire. And it provided us an opportunity to look at the ability of chaparral to regenerate after very long intervals without fire. And we found areas that were using rings on skeletons of manzanitas. We found areas that had gone 150 years without a fire. And there were also areas that were more typical of mature chaparral, 50 or 60 years. And we contrasted the recovery under those two landscapes, asking the question, do ancient chaparral landscapes, are they actually exposed to senescent risk? In other words, do they not recover well after a fire? And the bottom line is, if you look at a lot of different parameters, this is, for example, species diversity at different scales and cover values. The bottom line is ancient stands seem to regenerate just fine. It doesn't mean there's no effect. For example, the obligate seeding ceanothus, after fire and 50-year-old stands, we might have 50 seedlings per square meter. In the ancient stands, it might be maybe only 5. But still, there is the potential for replacement of those original populations. So there's not a lot of reason to believe that senescence risk is a big issue. There's generally no lack of fire, and these ecosystems are resilient to very long intervals. Now let's look at immaturity risk. Now back in the 1970s, Charles Philpott developed a number of models to predict fire spread. And one of the things that was interpreted from these models was the idea that immaturity risk is not an issue in these systems. Because basically, he assumed that younger stands simply didn't have enough fuel to carry fire. And this was largely based on prescribed burn studies that have been done in the past by rangeland managers who tried to type convert chaparral to grasslands to make it more productive because they didn't want this worthless chaparral. And what they found is it's really hard to type convert chaparral by burning. And instead, they tended to prefer things such as herbicides and bulldozers to type convert. Now, recently there was a paper that came out that actually took these observations and proposed the hypothesis that maybe type conversion really isn't an issue in these landscapes because the rangeland managers gave up trying to burn these landscapes with prescription burns because they couldn't get fires to burn under short fire return intervals. However, there's a really important mistake in that logic, and that is that prescription burns are done under conditions that are not favorable to fire spread. And wildland fires often don't. This is not a prescription burn here. This is a wildland fire that's burning with probably 100 kilometer per hour wind gusts, relative humidity is below 5%. And under those conditions, we found you can readily get fire to spread in very young stands. Now, another aspect to the studies by Philpott et al. Is that they looked at mainly just shrub cover, and they started at about 10 years. At about 10 years in chaparral, actually the ratio of live fuels to dead fuels is pretty high. They don't have a lot of really potentially hazardous fuels in 10-year-old stands, and over time they accumulate, and that leads to greater fire. But they essentially interpolated this to also mean that as you go back in time, the fuels go down. And so if fires don't burn very well in 10-year-old stands, they're probably not going to burn very well in very young stands. But what they missed in this is what happens with the post-fire ephemeral flora, which are short-lived species that create really hazardous fuels in the first couple of years. And this is just a site that's 5 years after a fire, and all that brown is the species formerly known as Lotus scoparius, and I can't pronounce the new name. And so we believe that if you look at fuels in chaparral systems, they actually rise and are pretty high in the first 5 years after fire, and then they decline as the shrubs come in, shake out the ephemerals, and then the fuels increase again. And it's in these younger stands where we actually can get fires reburning, particularly under Santa Ana wind conditions, where you get these high-speed winds blowing fires from the interior out. And we saw an example of this in San Diego County in the last decade, where this green represents the cedar fire and in 2003, and then the yellow represents the witch fire. And the witch fire reburned a huge portion of the cedar fire, and this overlap area is an area which is really a fire return interval that is probably too short for many chaparral species to regenerate. And we looked at this cedar fire, and you can see the effect of different pre-fire ages. This is just looking at the cedar fire, not looking at the witch fire. And in the first year after fire, this was part of the cedar fire that had only been 3 years old time of fire. This is what it was, part of it that was 24 years. Here we're getting natural regeneration of the chaparral. Here we're getting it infested with alien grasses, and those grasses invade and they increase the flammability of those systems and encourage repeat fires. 4 years later, these areas reburned, and if you look at just areas that burned in 2003 and 2007, basically what you see is after that second burn, the witch fire, aliens go way up in these sites. So there's good evidence on the ground that these stands are susceptible to being type converted. And we can see lots of instances around Southern California. This is an area in Jan Byer's backyard. This is Box Springs Mountain, It's an area that historically was coastal sage chaparral. Now it's really degraded shrubland with lots of exotic grasslands. And part of the reason for that is they've had a very complex fire history. These are all the fires that are recorded up on Box Springs Mountain. So they just get repeat fires one after another. And that really leads to type conversion. And it's a feedback process because we've looked at ignitions recently. And one of the things you see in Southern California is most of our fires begin in grass. They'll spread to shrublands, but grass is an important part of the wick that leads to the fires spreading into these other systems. So basically, let me just conclude with a few comments about what this suggests to us in terms of fire management versus resource in these systems. We don't believe senescence risk is a big risk in shrublands on these current landscapes. And what we derive from that is if you do prescription burning in chaparral, you shouldn't, as some proponents have said, say this is a win-win proposition, good for resources, good for fire hazard reduction. There really is no reason to say it's good for resources because these systems are not limited by the amount of fire. If you propose doing prescription burns, it needs to be evaluated solely on its effectiveness for reducing fire hazard and not on its effect on resources. Immaturity risk, on the other hand, is a real problem on these landscapes. And it suggests that by adding prescription burning, one of the things you're doing is adding to the fire load on that landscape, which could exacerbate an area that already has probably too much fires. And so it potentially could have negative impacts. It doesn't necessarily have to have negative impacts, but it potentially could. Let me just end with one last comment, and that is about the future in this landscape. A lot of people are concerned about global warming and its impact on fires in these landscapes. Well, it's probably true in a lot of landscapes, and we have a paper coming out this week that deals with historical fire-climate relationships. And in the high elevations, you do see really marked climate signals. You get into the lower elevations and we don't see it. And part of the reason is that 99%, at least in Southern California, of all lands are burned by human-ignited fires. Now, in terms of the future, you have to recognize that our landscapes are still growing demographically. We're expected to add 50% of our population in the next 3 decades. And so people are starting most of the fires, and they're going to increase their impact potentially in the future. Whereas warming, it's predicted to increase maybe 2 to 3%, and potentially will have far less impact, at least in the lower human-dominated landscapes. Thank you.